Hi everyone, I'm super excited to host Dr. Yoav Vered, CTO of Zen Acoustics. Thanks a lot for being on the show.
Thank you very
So, take us back to your early career days and what were you excited about? What were your career highlights?
Sure. So I began my career in academia. I've started at the Technion, which is in Israel. It's the Israel Institute of Technology, where I did my PhD in the Faculty of Mechanical Engineering. My research topic was underwater acoustics and the way the acoustic waves interact with solids, which is very intriguing and very fascinating world for me, because I came from a mechanical background and all of the way start to understand the wave dynamics and to think of the waves and the effect happening underwater was very fascinating. Then I continued and started a postdoc research as a research associate at the University of Southampton in United Kingdom at the Institute of Sound and Vibration Research, where I mainly investigated digital twins and their effect in active control of noise and vibrations, which is a fascinating topic as well. See, this day we have hypercomputers, and in the AI age, we even have super servers, and so simulation capabilities grew on order of magnitude compared to the previous century. And the question of how to use those simulations the best to our knowledge of control system, of real-time control system, is still an open question. Many of the industrial controllers are still working similar to the way they worked 20 years ago, using a PLC controller or a PID controller, which are kind of the go-to in the industry. And my research focused on how to elevate it and to use a more complex controller using the digital twin and the knowledge we have on the system. And then I started to look into active noise control, similar to the one we have in most of our earphones and headphones today, which is, again, a technology that has been known for almost 100 years now, but only really started to change our lives and come into play during the last 10 or 15 years. And this day it is very common. Every set of headphones and earphones you buy, you have ANC, active noise control or active noise cancellation, built in them. So I did a research both on the headphones to improve the response of ANC system to different direction of arrival of the noise. And I did a research in ANC in automotive, where you have a problem. This day we have many electrical vehicles, meaning that the motor noise is much reduced. It is not as significant as before, but now people start to get annoyed by the road noise itself. So above a certain velocity of about 40 kilometers per hour, the road noise becomes significant. And it's mainly due to the tires and the friction of the tire and wheel with the road. So there isn't much to do about it from the mechanical perspective, although there are some development in that area as well, but you can do a lot using similar principles to active noise control of earphones in the car, where you can measure the vibration of the wheels and then try to create an anti-noise to reduce the overall noise that built up inside the car. So that was my first introduction of the technology of ANC, which now we are working on in Zen. So once I've completed my postdoc at the Institute of Sound and Vibration Research, I've met with my partner, Technion Rosenthal, who is not here with us today, but he is Zen's CEO, and he just bought a new apartment in Israel in one of the nice buildings. I think you can see the same buildings now everywhere throughout the world. You have a nice building with a large balcony and open window to the view. Unfortunately, once he opened the window, he got hit with a wall of noise coming from the highway underneath the building. He approaches me and asks, can we apply similar principle to the one we have in earphones and the one in automotive uh, to openings in buildings, specifically windows or balconies, to attenuate the environmental noise. And that is basically what we've been working on in Zen's for the past year. As you can see, I'm now sitting in our acoustic lab where we have developed a POC to attenuate environmental noise. And we are now, it's a technology still in development. We are now taking the next step to take the technology from the lab to the outside world and test it in real environment.
Such an incredible journey, like from mechanical PhD and from applying this technology and borrowing it from other domains in construction. It's really fascinating to see. I was curious, the point you mentioned about digital twins. What was your major findings in that project?
Basically, my part of the project was to improve our understanding of how to take the knowledge of digital twin, which are not just a computer simulation. Digital twin, by definition, is a living environment inside the digital world, which replicates a real system or real system of systems, usually. And my part was to understand how we can better suit a control system, classical control system, to a digital twin and vice versa to the real physical twin. For example, if you consider the control surface of an airplane, so an airplane has uh, three different control mechanisms. One of them is a control surface of the wings, which can come up and down when you want to uh, decrease or increase the flight speed. However, usually the control mechanism, the control surface itself has some nonlinearity in it in the form of backlash, which means that when you turn direction, you get a dead zone in the movement where you expect the control surface to move because you put power into the engine or into your hydraulic pump, but it doesn't respond immediately. It takes some time to respond. And the backlash may change during the lifetime of the system. So one of my publication was regarding nonlinear control of backlash and how we can use the digital twin in order to understand the amount of backlash currently in the system and then change one of the control parameters in order to better suit the current situation without having hard limits on our performance. And similarly, if I'm taking it from the mechanical world to the acoustic world, in the acoustic world, usually we have a few measured points. We can measure the pressure using microphones, or we can measure the vibration of a surface using accelerometers, but we can only measure a few points. However, the acoustic environment has much more information in it. It has the pressure and the vector velocity at each point in the acoustic domain, physical domain. And we can only obtain that information, which is crucial in order to get a good spatial active noise control if we use an elaborate model or a digital twin, which can analyze in real time the performance and the acoustic characteristics of the room using only a few points.
Got it. And tell us how your first year of building this looked like, because I'm trying to imagine how testing works, how ideation works, lab prototypes versus real world testing.
My job is to mainly focus on the technology, but at the same time as I'm focused on the development of the technology, which I'll answer shortly of how a day in the lab looks. I'm also always thinking as a startup of the possible use case and what product can come and use the technology we're building. That is a very intriguing process, especially when you come from engineer and then you start and think about the business side of things. And that is what got me excited to work and to develop a young startup where you have both the technological R&D, but you also have the business R&D, and you try to meet with different construction companies and developers, windows and shades companies in order to understand how your technology can fit in their products or in their needs. And it is very intriguing. Basically, what I'm doing most of the time is developing the technology, which means setting up KPIs for our development and then trying to obtain them in the lab and then in the real world, which means that we have an acoustic room. Right now, I'm sitting inside a old British safe room in Haifa, in the port of Haifa, uh, which was built in the about 100 years ago, in the 20s of the last century. And I have to my left an anechoic room where I can create noises that imitate the outside environmental noise. And between the anechoic room and my room, there is an opening where there is a sensor and loudspeakers, which I can measure and control in order to cancel out and attenuate the environmental noise I'm creating in the anechoic chamber. And most of the day is between experimentation and understanding the behavior of the control system and develop the underlying architecture required in order to implement the control system itself. Meaning that I get to work with a lot of equipment and hardware here, from microphones, loudspeakers to amplifiers and preamplifiers in order to excite them and measure them. We're also, all the control is realized in real time using an FPGA that we program ourselves. So it also has to have a lot of hardware and logic design in it, which means that uh, every day is a puzzle. You start working on a piece and you have to figure out how to implement it on the FPGA using the amount of resources you have. And then you need to measure everything in the lab to see that you really made the difference.
I see. So the setup itself is a bit complicated, and you have to spend time on building the internal labs.
But also it is not a computer-based control. Once you move to real-time systems, everything has to be executed at the right time, and you have to understand and program your real-time system in order to behave as you wanted it to behave. I think it is very interesting, but very challenging at the same time.
So how does the final product look like for the use case you mentioned about, like in a high rise, when you open the window, you hear the noise? Like, how does this final
Yes.
product?
So it is a bit hard to imagine because there isn't a product like it as far as I'm aware of. But we're not focused right now on a single product. Instead, we're focused on developing the technology and finding the right strategic partner and design partners in order to get the technology into as many products as possible. So let's for example, think of a window company which sell, which makes windows for new houses, and our technology is integrated in their window, meaning that there will be a sensor outside of the window connected probably to the aluminum frame of the window, and there are loudspeakers integrated inside of the frame itself. And then if you open the window by a small amount, the system will work and attenuate the noise. And if you want a fully open window, you can still do that, but then the system will not work as efficiently. So that is one uh, ideation we have about what is usually referred to in the construction industry as a pre-market product, where you sell it to the developers and to the construction agencies. And we can also think of the technology as an aftermarket product. For example, as a partner Pniel figured out after he bought the house that the highway is very noisy and it disturbed his day-to-day life in the apartment. I reckon many people already bought houses and apartment and will want the technology. So we can integrate it, for example, in bars, where you can come and install the bars outside of the window. There will be a sensor installed at the bottom bar or fixed to the outer wall of the building, and there will be loudspeakers integrated inside the bars in a fashion manner to counteract the environmental noise and create the anti-noise. And basically, our product then is the control unit itself, which you can think of it as a small PC or small modem or box situated near the window, which can collect the acoustic sensor data, compute based on it acoustic properties and acoustic feature we are interested in, and then create and send to the loudspeaker the anti-noise needed to attenuate the incident environmental noise.
It's adaptive based on the condition. That's it.
Yeah, so it can have adaptive properties, but it mainly works not necessarily adaptive, but it reacts always
Mm.
to the environment. So it has to have some kind of a sensing mechanism in order to react to what is currently the noise outside. Because, for example, if you think of the highway case, a private car, a motorcycle, and a truck all create different sound and noise signature. And you cannot know beforehand which one is going to pass on the road at any certain moment. And we don't want to include any additional image processing to our product. So once you have the acoustic sensor, you are capable of having some kind of a feed forward knowledge of what is the incident noise. And then you can create, and it has to be very fast in order
Mm.
to create an anti-noise for that incident noise, which in turn use the wave superposition principle, meaning that the noise plus the anti-noise will sum up together, but because they are in opposite phases, they will cancel out. And that's how we get the attenuation.
Makes a lot of sense. For a founder who's trying to build in the building hardware or technology space, which could be as complex as what you're building, what would be your piece of advice if they're starting right now?
I think that it's the same piece of advice we're still using is to explore as many options as possible to begin with, because you don't really know what is the best early adopters your technology will be used by. What I mean is that, of course, if we're speaking about volume, uh, based on the previous use cases I mentioned, the best volume is to integrate our technology with Windows, because every apartment has Windows, more one window, they are already there. So it is not such a large leap from the current situation. However, for our case at least, we currently feel that the early adopters are not necessarily the construction companies. Instead, they might be people who really suffer from the environmental noise currently in their home and want a solution which will be easy to install. They don't want to start renovate the entire apartment. And that's really the realization that this probably, and I'm saying probably because we are still young, but probably our early adopters made us change how we develop our technology currently, and it focused us on what are R&D crucial steps in order to obtain the right technology for that specific use case.
We have a rapid fire round. You have less than 10 seconds to answer, and you have to keep it super brief. So, first one is, what's your favorite restaurant?
Thai food.
It's any book which made a big impact in your life?
Yeah, Song of Ice and Fire.
What's your favorite movie?
Favorite movie? It's hard to tell, but probably the most impactful one was Lord of the Ring.
A city which is in your travel bucket list?
Not because I've been lots throughout the world, but I would say that one that is still on my bucket list is Buenos Aires in Argentina.
3 words your co-founder would describe you as?
Motivated, perfectionist, and probably workaholic.
I see. What would be the piece of advice you would give to your 18-year-old self?
Don't give up and always continue growing and learning.
What are some other exciting and challenging problems you think there are opportunities to solve, but in case you had more time and resources?
That's a tough question. I think there is uh, still a lot to improve in smart homes by themselves. At Zen's, we're mainly focused on the acoustic part and the acoustic control, but smart homes are still uh, somewhere a nice idea, but it's not really an automated feature that can learn your behavior and react to it.
Is there anything which we didn't cover in this interview and you would like to end on that closing note?
Yeah, I think that probably because I'm always enthusiastic about our technology, it is still something that we don't really appreciate. Like you enter your home, this day, most chances is that you have a temperature control unit, like an AC, but we still don't have any way other than putting earphones and disconnected from our environment to really control our acoustic surroundings. So what we're aiming at in Zense is to really change the way we control our acoustic environment and allow us to shape it to our liking.
That's very exciting and amazing future. Like I can imagine entering the house and like, okay, reduce the
Yeah,
noise and
I
so
don't
that would
know
be
how we
awesome.
lived. I have no idea how we lived so far without it. I'm sure that once people will have the ability, they will forget how it was before.
Never going back. Thanks a lot for your time to do this.
Thank you very much.